ago. I spent a month there on the main, on Bali Island.
Where did you go?
Oh, I went to, like, I lived near Kuta, Canggu Beach.
Oh, yeah. My house near Canggu.
Right, okay. Yeah, so there and then went all the way up to Lovisa. Slovenia. Singaraya. And
Singaraja.
oh, there you go. Yeah, it's like, oh, you've been around.
Oh, you've been everywhere in Bali, right?
No, I haven't been to East.
Just East,
yeah. Interesting. Been to Wood as well.
I love it.
Yeah, it's pretty cool. And then I actually went to Gili Island last year.
That's
I didn't go to Lombok, but it was, we went to Gili, not Manor. I can't remember, one of the Gili Islands. Not Gili Manor and not Gili, that's Sawangan. Not that, the third one. Yeah.
Good morning, everyone. How are you all doing?
Getting a little bit worried.
Are you? No. Why?
I'm just like, I'm worried that, like, am I capturing enough information?
Oh, yes. You are. Plenty. And I wouldn't worry too much. Sandra and I won't let you fail. So we won't let you make a mistake. We'll always correct you and make sure that you get the feedback that you need to be able to succeed. So don't panic. It might feel a little bit, I can understand where you're coming from, where the information is coming thick and fast and you don't really know which bits are more important than the others. That's a really unfortunate consequence of early learning, is that it's hard to know what the emphasis is important or not. But you'll hear me say occasionally, that'll go in the report.
Yeah.
That's your note to go, I better make sure I really got that one. So I'm emphasising for you. And we'll do a quick recap this morning of what we covered yesterday afternoon, just to bring Adriana up to speed and to give us a reminder of where we were yesterday. And at this point, you're mostly just looking at a list. You just need a list of all the different types of construction systems for each component of the project, and then you can embellish that into a full sentence and have some diagrams from the textbook to illustrate what you're saying, and that's all you really need to worry about.
Because, I feel like, what we write on the drawings, it could be endless, but then it could be too crowded.
Yeah, no, what you've got on the drawings is all that you need. Everything that we've mentioned, that's the end of it. We're actually doing it as we go.
Okay.
Yeah, the construction system's a little different, where you will end up taking what we do today and turning it into something that looks a bit like a short paragraph about the footing, for example. You might name the footing and then have a diagram, and then the floor slab, and then the diagram, and then the walls, and then a diagram. So you'll embellish that a little bit in the report, but the drawings are done. That's the end of it.
So we don't have to...
No more.
Right.
No, you'll not be doing any further research or adding anything more to the drawings. That's already complete.
And that's if I've got everything that needs to be on there.
Yeah. Good morning. No, don't be. We're still waiting on one as well, so we're just sort of doing a quick recap of yesterday afternoon while we wait.
Oh, cool.
You're fine.
When I was kind of looking at your drawings, you got way more information.
Have I? I probably just write too much. I wouldn't be too concerned. And some of these are old and things, yeah. But we can do like a little tidy up next week. We can go through page by page and just double check.
That would be
amazing.
Yeah,
no problem. Yep, I wasn't going to let you flounder.
Yeah. But I'm kind of like starting to see that things are going to get a bit hectic.
They do get a little hectic, yes. You're not wrong. That's fairly accurate.
And like looking even like the assessment sheets and what we need to know and what we have to do.
Yep. Yeah, no. I guess the good thing about the assessment sheet is that's the extent of it. What you see, that's it. There's no extra. There's no, discuss this or analyse that. It's simply just do, stop. So it's not too bad. There is a limit because, like you said, it could go on forever. I mean, when you think about the design process, I'm sure if I was given all the time in the world to design a project, I would just keep designing it forever. because it could always be more perfect, couldn't it?
You would just like sit and look and
Yeah,
what
yeah.
can I do to make it better?
Yeah, yeah. Research different products, different materials. It would be endless. It really would. So you do have to draw a line in the, just say, that's enough. Time to stop. Otherwise you would never get it built, would you? All right. So yesterday we talked about going from very, very early rough sketches to a more developed return brief that we could use to inform the process. So this is very early days in the design and construct project, where we're looking for lots of information about the characteristics or attributes of the site and the proposed design and how that will reflect in the regulations. So it's really about making sure that all the regulations are going to be met, and if they're not going to be met, what we might do about that. So it gets progressed from here to a little bit more detail with some dimensions and some indications of what the materials might be, and you get, Revit gives you a fantastic three-dimensional image so that you can see a bit of a picture of what it might look like and make sure the aesthetics are achieved. In the planning scheme, that final clause about the design and making sure there isn't a large expanse of single walls has already been achieved with the modulation of the elevations and some exterior materials. And then yesterday we started from the ground up, and yesterday we talked about what construction systems we might like to specify, what we might think will work for the different regulations, aesthetic requirements, and the brief and the budget and the time frame might work well for this project. What was the first thing that we picked up on yesterday when we were talking about the construction system? Remember? Help Adriana out? Yeah. So we talked a bit about the site first and what that might mean for the foundations. Yeah. So what footing did we decide would probably most likely be determined by the engineer to be used? Do you remember? Concrete, yes. What kind of concrete? The pad footing, yep. So a big square, basically, yep. And what else is in that footing? Reinforcing, correct, absolutely. So concrete and steel together so that the combined strength of the two cancels out the weaknesses of the other. So they both have different characteristics. Steel is very strong in tensile strength, so you can stretch it and it won't break. And concrete is very strong in compressive strength, so you can crush it and it won't break. So those two things together work really well. So reinforced concrete is extremely versatile. So yeah, we did recommend that perhaps on the ground floor where we were looking at the carport, the car park downstairs and the barbecue area and the outdoor area and the bin enclosure and the storerooms and the lift and the stairs, we were looking at the proposed structure that was already being set up for us, and we identified these rectangles in the car park. What do they refer to?
Columns.
Yeah, yeah. And so we wanted to offer a suggestion of an ideal footing underneath those columns, and that was the pad footing that we talked about. Because it's a site S class, we're predicting that deeper footings is probably not necessary because it's quite a stable site. And then, I don't know if we actually did this yesterday, but what footings did we determine would be ideal for the other structural walls? I don't think we did that. No, we skipped that, but I made a bit of a mistake there. So let's pick that up now. What would be the ideal footing underneath the structural walls that are also doing some load-bearing work on the ground floor?
I don't know if I've got this word right, edge beam?
Yeah, or an edge beam is where it's on the edge of something, but these are somewhat independent, aren't they?
Yeah.
So if it wasn't the edge of the footing, it wasn't the edge of something, it would be the same shape, but it's called a strip footing because it just goes in a long strip. Yeah. So this wall here that we were talking about rendering and only painting one side is going to have a big square strip footing underneath it. But under the storerooms you might have an edge beam, an edge footing under that because there's a slab, a floor slab there.
Would there be one here because are we going to do just a slab for this? Were they two separate?
Well, this will be a separate slab, but that's an outdoor slab that's non-load bearing, and you would have an independent strip footing under that load bearing wall of its own, definitely. Yep. Yeah, so just add that to the list, an independent strip footing underneath the load bearing reinforced concrete blockwork walls on the ground floor. an oversight there that we missed that. Lucky we picked it up. So the bin enclosure is only very light, and you would probably just use a very small edge beam underneath that because it's not a habitable room. It's not a place where people go. It's simply just a fence, basically, for the bins to hide behind. But that would be a thickened edge slab under the bin enclosure. And then there would be a little bit more load-bearing work by the storerooms at the back here. So they would have a thickened edge beam under them as well. And then there would be quite a significant footing underneath the lift shaft, wouldn't there? Because that's a very tall, independent structure. So it would have a very significant footing underneath that. And then the concrete slab would be independent. So the engineer would have to determine what that looked like.
Sorry, Lisa, what was that again under the lift?
Yeah, so the lift would need its own footings.
Okay.
But I couldn't even guess what an engineer would say about that. So it might just be a really large pad for the whole lift structure.
Okay. So I'll probably just put it independent.
Just independent lift shaft footing as per engineer specifications.
So this will move next to the stairs?
Yeah, that'll have its own strip footing as well. Yep, yep. And then we talked about the slab finish, and we talked about the driveway and the car park areas just being left as screed concrete, nothing special, but that we might put porcelain tiles in the barbecue area, non-slip porcelain tiles in the barbecue area. And what did we decide for the footpath and the...
Footpath is center concrete.
Oh, yeah. And we suggested perhaps we might put a colour oxide in it or some pebblecrete on there if we were feeling fancy. So some options for this entrance here that takes the pedestrians down to the, take the visitors down to the stairway or the lift. Most people will drive in, get out of their car and walk around the other side, but we were just accenting the pedestrian access and making it a little bit more pleasant. And then we've got this little room here by the barbecue area, which we aren't really sure what it's going to be used for at this stage, but it could be a toilet or it could be where the pool pump is going to go. Probably a toilet, considering it's got a window and a door. But it'll have its own thickened edge footing as well. And then we were saying rendered painted blockwork downstairs, is that right? Yeah. So the walls downstairs? Yeah. Yep. So we talked about the concrete columns being load-bearing, but that they're a point load underneath a slab above, and that perhaps there might need to be a pad at the top as well, just to spread the load out underneath the upper slab. Again, that's up to the engineer, but something that we might suggest could be a requirement of the construction system. Then what did we come across? Next level up. What was next after the ground floor?
The first floor slab.
Yeah.
That would be
Yeah. And what did we call that one specially?
Transfer.
The transfer slab, yes. Yep.
I mean transom. I was like, that's not
That's
transom.
close,
Like,
yeah.
I'm like, that's not right, so I didn't say it.
No, you're right. Transfer slab. And we talked about how the load movement above it will be different to the load movement below, and so you need a concrete slab that can transfer the loads from one place to another and down to the ground. Because the walls are the same for the 3 stories above, so the loads will move down the building quite easily, but once they get to that slab above the car park, they have to move into different directions and then go down the columns and down to the ground. So that concrete slab is called a transfer slab because it moves the loads horizontally and then down to the columns. And we proposed that it probably would be about 450 millimetres thick. Is that right? Yeah, which is quite large for a slab, but it has to do a lot of work, so we have to make that a little bit emphasised. And we talked about the fact that we need to know some of these things early in the project to determine the overall height of the project and also to help us model it up in Revit accurately so that if it does go back to the engineers for markups or if it goes to the planning department for approval, then they've got an accurate depiction of what the end product is really going to be like. Because if it ends up getting changed or built differently and you add, say if we only put 200 millimetres thick for that slab, not realising it needed to be wider, then if we sent it to the engineers and they upgraded it to 450 millimetres, we would probably have to send that back to the planning department for an amendment, and that takes quite a bit of work and time. We don't really want to do that if we can help it. So try and learn these things in advance from the engineers so that it can be built into the project right from the beginning. It's a fairly typical phenomenon, so it's quite common at that point in most high-rise buildings to put a thicker slab. And we were just talking about pouring that concrete on site, weren't we? An in situ, 2-way reinforced concrete transfer slab. Suspended, yeah, suspended slab, because you have to hold the formwork up in the air. You have to suspend it in midair like a magician and build the formwork to hold the wet concrete and then bring a concrete truck and a pump, you know those pumps with the big arm and the tube, and then pump the concrete up onto the first floor. So we use scaffolding and props to hold up the formwork. And for big projects like that, the formwork is usually a big square panel and they come in modular units and you simply just bring them onto site and lock them all together. And they're usually 2 pieces of steel separated by different framework inside, plastic or polystyrene or something like that, that can create stability enough to hold all that weight, because the support has to be quite strong to be able to hold all the people and the machines and the concrete and everything else until it's able to cure and support itself. And then it moves up a level once the blockwork's done. And what sort of a finish were we talking about leaving on that concrete? Did we mention that? Scratch coat? Oh, that was the downstairs render, wasn't it, the scratch coat? Yeah, yeah. Oh, yeah, so the render downstairs, we were talking about having a scratch coat finish. That's a little bit more economical and easier to achieve than a perfect render, scratch coat, which is the downstairs, and it'll be all the other blockwork render as well, yeah. And it just leaves a little scratch in the render as you put it on. But the slab itself, the edge that you can see, will probably just be sealed and then painted. We probably wouldn't render the protrusion, you know, that transom that you're talking about. We probably wouldn't render that because it's such a small piece of concrete. It would be difficult to maintain that render easily. Over a big expanse, the render stays, it's more stable, it doesn't flake away, it doesn't chip off. But on a small piece where there's not a great deal to adhere, it probably would perhaps break away after a few years. So perhaps just a painted edge might be better.
Along here only.
Yeah, on the face of the slab. And the underside as well, you wouldn't be able to render underneath easily, so it would probably just be simpler to paint it. What do you think, Andy? Painting okay?
Yes.
Yeah. On the balconies themselves, we might give it a finish.
So we transom and underside.
the underside of the overhang. Yeah, just paint the face of the slab and the underside of the slab.
And waterproof it.
Yeah, so it gets sealed first, and then you can paint it whatever colour you want. Yeah. And the seal looks like a paint, just white paint, but it looks like it's got a sealant and it's quite porous and it goes in and then...
Like an undercoat.
Very much. Yep. So that was a 450 millimetre, and we talked about the overall height of that slab, didn't we? What was the underside measurement of that first slab?
4 meters.
4 metres. So we talked about enough height for big vehicles and maybe caravans or boats, and then a bit of room for ducting and servicing. We don't have too much in the way of HVAC ducting, but we do have pipe work and services and things like that, you know, so fire, water and sewer. So we just wanted to make sure we had more than enough room. 4 metres is a bit excessive, but better safe than sorry. If you've got the room, we can probably take it. They're building a stadium at Marara at the moment, right by the road.
Go and take a photo. I work there every Thursday.
Do you?
Every Thursday.
Wow.
And every week I see it changing. And
That's
I just
amazing.
added more of the front. And I was like, oh, that's precast. That's that. You know, I was gonna take. I walked in. I was gonna take photos because you see the ducting. I
Yeah, do it.
Of everything. And I was like, oh, I should have done it. I was like, I want to look at the photos.
Yes. Yeah.
Oh, but it looks so good now. Like yeah.
Go for a bit of a drive on the weekend. Yeah.
Where are you,
Just near the airport. Yeah, there's a new stadium being built just adjacent to McMillan's Road. So you can get off McMillan's Road and go in and then drive past and see if you can see anything. Yeah.
They had these big precast walls and they had all the
props
there holding it, and I was like, oh,
I know what that is.
Yeah. I get some of this, not all of it, but I'm getting it. Like, and you can see all like the beams and stuff we were talking about yesterday, and I was like, oh, I'm like, this is cool. Like.
That's terrific. Go check it out. So it'll be a new sports arena. Excellent. All right. Very good. So then we have what on top of the slab?
The wall.
This is kind of where we got to yesterday, wasn't it? Yeah. Did we get to here or did we go further?
No,
we talked about, we went all the way up to the roof, didn't we? So we very quickly went up the building. So we said there would be 2,700 high blockwork reinforced concrete walls that were load bearing on each floor. We talked about the fact that perhaps further height might be wise to make sure we've got enough room for ceiling battens, services and fans, but I suspect 2,700 is significant enough because we just need enough height for the 2.4 that the NCC requires, so that's 300 millimetres that we've got to work with for fans and ducting and things like that, so I think we're okay. A really nice design, it occurred to me last night, a really nice design that I saw once, it was in a Class 1 building, was where a fan had been recessed. So this is the ceiling line here, and there was actually a recess, and the fan was in the top plane. So there was... the ceiling dropped down on the outside and went up in the middle and the fan was in there. So I thought it was really cool. We could perhaps have a play with that, you know, in our design and have something with a bit of a feature, particularly in the bedrooms.
But it doesn't affect the wind flow like
The fan blade sat right where the where the ceiling sat, so it probably was just low enough to still be able to oscillate the air. It's possible. There were beautiful big open doors out of a big beach, and it was all, you know, so they weren't short of a breeze. You know. It was a fancy photo, don't get me wrong. It was a good concept. And you can do that sometimes underneath elevated houses where you don't have a lot of head height, but you still want to have a fan. You can just pop the fan up in between the joists and or in between the bearers, and then it's not so low. Can be tricky. All right, so we said blockwork on the ground floor, and then we had a slab above that, didn't we? Another ceiling that acts as the floor for the floor above. What did we say that was made out of? Andy, what's the next slab made out of?
Mm, 'cause, 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 '
You're right. So we've got the columns on the ground floor. Then we've got a suspended reinforced concrete two-way slab for the big transfer slab. So there's where the cars go first, and then we've got the slab, and then there's walls for the next story up. Let me see if I can. So we've got the carport here, the car park. I've got to stop calling it a carport. It's a car park. And then see how this is thicker. So that's the 450 thick transfer slab there. Then we've got this story of walls, blockwork, load-bearing, reinforced concrete blockwork walls, 2.7 metres high. And then we've got another horizontal construction here. What's that?
It's called... I don't know.
So this one here, this line here, gives us a floor. It's the ceiling for the floor below, but it's also the floor for the next story up, isn't it?
Yes.
So this has to be made of something strong enough to be able to hold all this material up here, which is quite heavy. So this needs to be very strong. So I would recommend concrete. What do you think?
Yeah.
Sounds like a good idea? So this slab here doesn't need to be as thick as this one, because the loads here are repeated. You can see this is all lined up, it's the same. So the weight of this material will come directly down, but when it gets to here, it needs to move to somewhere else because there's nothing beneath it. So it needs to move and go down to the ground in a different way. So that's why this slab needs to be so much thicker. But this one doesn't need to be quite as substantial, so 200 millimetres thick is probably sufficient to be able to do the structural work that it needs to do. But it needs to be reinforced. Would you agree, Andy?
Yep.
This one here. So steel and concrete in combination. So a 200 thick, two-way slab, suspended and reinforced. And then we'll simply repeat that same pattern for the next floor, wouldn't we?
Yeah, blockwork underneath. I mean, yeah, underneath.
Yeah.
Whereas for the last one, there's no blockwork.
There's nothing there.
Yeah,
Yep,
so
yep.
we
The
would
supports are in different places.
We would need the column.
Yep, yep. So we've got a 200 slab here, and then a repetition of the construction above that. So 200 series reinforced concrete blockwork walls. And then something else here. What's this horizontal here? What do you think, Andy? So we've got this line here. You see that there?
Yeah.
What does that refer to, do you think?
Concrete?
Yeah, it's the same thing again, isn't it?
Yeah.
Yeah, so another 200 series reinforced concrete two-way slab. Two-way being that there's reinforcing going in two directions. And then we've got the final story upstairs, which is still a repetition, so 200 series blockwork concrete walling. What have we got here? What's this here? Right at the very top. You see that there? What have they got on the top of the building? You see that there?
Is it same thing?
Yeah. But do you remember Sandra mentioned yesterday to change this one a little bit for a particular reason? Did you take a note of that by any chance?
I think yes.
Yeah? See if you can see it in your notes. Is it there?
Is it still sitting?
What's that?
Still sitting?
No, that's probably the fly roof. So we've got this slab on the roof, which is excellent high thermal mass construction, and the system beneath it can support it easily. And it could be just the same 200 millimetre thick slab as the rest of the slabs have been. But what Sandra suggested you might want to do is make it 250 millimetres thick so that you've got some opportunity to reduce that down to 200, where you might want to create a fall for drainage. So if it's more at one end, it can be lower at the left, but the least is 200. So then the structural work is still in place. So the roof slab, we're nominating or proposing that that be 250 millimetres thick to allow for drainage, for a fall for drainage, because you have to reduce the overall height gradually so that the water can run in a certain direction. And if you're going to reduce the overall height, then the thickness of the concrete would be diminished, and we would lose structural capability. If we were starting at 200, we might go down to 150 to achieve that fall, that thickness. We don't really want to do that. So rather than doing that, what Sandra's suggesting is that we have 250 here. So when it gets to the lower part here, that's 200, it's still structurally compliant. Whereas if we had started with 200 here and went down, we might end up with only 150 in the middle. And that might be too narrow to do the structural work, to be able to span the gaps underneath.
So 250 at
250, yeah. So you call it an overall 250 slab, even though it gets down to, say, 200. We don't really know what it will get down to, but it'd probably be a bit less than 250 and a bit more than 200. But it just depends on the fall. It only has to be a slight gradient. Water is very good at running down hills, so you only have to encourage it slightly. And we looked at the roof at that stage, didn't we? And we identified that we have a perimeter and then this vertical aspect up on that slab that perhaps we're proposing might be a parapet wall or an opportunity to show thickness in construction. Did we decide how tall that was? That blockwork on top of the concrete slab up on the roof?
600 mil.
Yeah, because we were looking at the size of it, weren't we, in the design and trying to determine how high we thought it was. It's not acting as a barrier for safety. It's not a trafficable roof. It's not a place that we're encouraging the general public to go to, so it doesn't have to act as a balustrade for a metre height. It's simply just an aesthetic, and it gives a way to do the same weatherproofing that we were discussing yesterday, where there was a small parapet on the slab. So we've got an opportunity there to weatherproof the roof, and we were discussing that there's this perimeter and it slightly matches the floor below's floor plan layout. And then we had this big fly roof on the very top, and you can see that in the 3D and the elevations. And it's just a lightweight steel structure right up on the roof. And it has a large roof and a small roof, but that they are pitched towards one another. So perhaps what we were suggesting is this area here, between the two roofs, that in the plan view shows, that actually lines up with the external area between the main units. It happens to line up sensibly where the main units are. So if by some unfortunate accident there is so much water in this place that it overflows the drainage, because we're likely to have a huge drain here that evacuates the water away and down the side of the building in downpipes and into the stormwater system connected under the ground. If for some reason that system either gets blocked or just can't cope with inundation that it receives, then there would be overflow. And the benefit of having that overflow directed to a location where it's outside people's homes means that they're not going to suffer inundation unnecessarily in their homes should that happen. So it's quite a sensible way to collect rain. Whereas if we didn't have these fly roofs, we wouldn't be able to provide shade for the concrete, but we also wouldn't be able to direct the water as well as we can. So we're capturing it and directing it. So there would be a huge drain underneath there. This then lines up with the open area downstairs to prevent the flooding should it ever occur. We talked about the construction of this fly roof as well. Purlin cross, what was that?
Cross
bracing.
Oh, cross bracing.
Yeah, so we were talking about having it connected as columns and beams. So steel, lightweight, well, it'll be quite significant steel, but it's lightweight construction because it's not concrete. Steel is quite lightweight, but it'll be column and beam construction with purlins, mid-span bracing and cladding.
Would you mind repeating that again? Column.
So what I'm proposing, and I can't sketch because I don't have the whiteboard in front of me, but perhaps I can do it here. Nope.
Paper?
Yeah, have you got kind of picture paper? Thank you. I have a habit of making these sketches into an absolute scribble, so I'll try not to. What we're looking at is most likely a reasonably simplistic frame that will most likely have 3, and so then the purlins go this way, and we talked about mid-span bracing yesterday, and we also talked about cross bracing. That was Nicole's excellent suggestion. So we end up with a big roof. What we've got is columns that are connected directly to the concrete slab, and then beams that run across those 2 columns. So we're probably looking at that I-shaped steel, because that's very strong and can go a long way. It can span a big gap and support its own weight quite sufficiently. And then purlins running the opposite way, and that would probably be those Cs, the light gauge C purlins that are on the shelf. And then we also talked about giving that a bit of stability by connecting those purlins together between the beams, mid-span, so mid-span bracing, just connecting those together. And then these big X's between all those squares to triangulate the frame, so all in the same pitch direction, all in that plane where the pitch is, and then you can put the roof sheeting straight over the top. And thankfully, I've done it well enough that the roof sheeting goes this way with the rain. Lucky. I have been known to do it wrong and have to rearrange things. So I'll write a little note on here. That's columns, beams, purlins. Can anybody remember the name of a purlin if it's on the walls? Girt. Well done, Nicole. That was very quick. So we probably would have girts along the side. Now, if you look at these purlins here, they've got to span from beam to beam. They've got to hold their own weight from there. And where I've used the same member, it's going from column to column, but that's almost twice as far in my diagram. So we might perhaps need to have an additional column coming down. Not that the beam needs to support, but that the girts need somewhere to rest. They need somewhere to connect. They can't go that far. They would wobble too much. So girts, and then you can have the steel cladding and it would be an overhang fly roof. And then we've got mid-span bracing. And cross bracing. I labelled everything, beams, girts. So I would imagine, and it would be up to the engineer, but I would imagine it would be the I-shape steel, universal columns and beams to create that frame. You could also use that triangulated girder truss, you know, the ones with the top and bottom steel and the big triangles in the middle. They go a long way too. That would be ideal in this situation because you're cladding over them, you can't see them. It doesn't matter that they're not very aesthetic. Now, where did I see? Oh, so I took my dog to the dog park in Palmerston yesterday afternoon, and they've got this massive shed. It was just a big shade structure with the bike racing underneath. Fantastic structure. Fantastic. So Marlowe's Lagoon in Palmerston, and you just drive off the road and around the back towards where the dog park entrance is, and there's this big curved shade structure, and it's terrific because it's in 3 parts. Whoops. So it's actually a 3-tiered, and then the structure is underneath. But they've used curved web trusses, if you like, to create the shed. Well, the shade. That's terrific.
This huge one.
Massive. Yeah. Yep.
But it's a new, fairly new.
Fairly new. Yep. You can see the lights when they're on from Tiger Brennan as you're coming towards the Durack roundabout where the service station is there, the Shell service station, as you're coming to Palmerston from Tiger Brennan Drive. It's terrific. You can get that if you like. Might be helpful. The only thing we didn't discuss yesterday is how we're going to connect the bottom of these columns to the slab. Now, we looked at a couple of images yesterday of that sort of thing. Does anybody remember what that might look like? Any volunteers?
I remember with the foundation, we just something in the book picture where we put like steel bed or something.
Yeah, that's the one. You have it.
Oh.
So we need a way to hold these columns to the concrete slab they're sitting on. It can't just rest there. It has to be connected because of one big wind and it's high up, so there would be a lot of wind. We just carry it away like an umbrella. So what we probably want to do is create the same kind of footing as Adriana is referencing. Where you've got a big plate of steel. You've got a big plate of steel bolted on top of a little concrete plinth to shed water. You've got these bolted into the concrete below, and then the column is welded to the plate. And this is these diagrams are exactly what you would include in your report. Quite simplistic diagrams. They don't have to be fancy. I've even gone all out and put the thickness there, but it's fairly messy. Like it's not fancy, but that's fancy enough. Because if you can label it, so you write in concrete, and I definitely prefer by hand, and then I scan it in and put it in my drawing. I'm not very good at drawing with a computer, so I just use the snipping tool, so scan it in from the photocopier and then take the image and pop it into the report, rather than trying to draw it using shapes in Word. It ends up just looking really difficult. But here you've got the bolts through, and that would sit in the slab beneath with that same threaded rod that I mentioned.
Oh, it's not straight.
It has to turn because the concrete slab beneath is only 200 millimetres thick. It can't go very far, otherwise it would poke out the other side. So it has to go through. And it's made out of the rod that is threaded, so you can connect the bolts to the top. And the engineer might say, make that go quite a long way, because there's significant uplift up there. So this is welded, this is bolted, and then that's concreted in. I would imagine that's how they would do it. And then all the other connections would simply be welded and bolted. Plates and cleats and bolts and welds. So these are good diagrams to kind of include to illustrate your point. But that would be a completely engineered scenario, and then the roof sheeting would be deemed to comply.
So our part is just to sort of propose these materials.
Pretty much that, yeah.
Can I take a photo?
You can keep it, scan it, keep it. Yeah, by all means, yeah.
Okay, I can photocopy it if you want.
And it'll come up again.
Oh, you want to copy it?
Yeah.
That's your phone then.
At the end of the year, you'll do a revisit to this project and start to develop it a bit further, so you'll pick that back up again and try and model it in Revit.
Ooh.
Uh-huh.
I haven't done that. I've just done all.
Yeah, it gets interesting, that's true. Is that where we got to yesterday?
Yeah.
Yeah.
Did we talk about the stairs?
No.
That was sort of next, wasn't it?
Yeah. But last note I have is cross bracing and mid span bracing.
Yeah, that's right. So cross bracing and mid span bracing for the fly roof.
So we just up to that.
All right. Well, we'll jump into the stairs then, because that's the next major structure, and it travels the whole building. So whatever we decide will work for the whole building. Having a bit of a look. No, you're fine.
I'm just checking what.
Deemed to comply. DTCM. Yeah. No, don't be sorry at all. Have we got any indication from the drawings, and I don't think we have we got any indication from the drawings at all as to what the construction of the stairs might like to be? We don't have any information at all, do we? It's all internal. Yep. And what rules do we have to comply with for the stairs? They're not fire rated. No. We'd like them to be non-combustible, I suppose, wouldn't we? That would be sensible. But they don't need to be fire isolated.
There's something about the going up and
the goings and rises?
Yeah.
Yep. So those same rules apply, don't they? We have the standard residential goings and rises rule and the 125 sphere gap. We can't have that any greater. Does anybody want to, it's open season on the stairs, does anybody have an idea of what they think we could make the stairs out of?
Maybe precast concrete.
Precast concrete. And what would be the benefit of precast concrete? So those ready-made stairs that Sandra was talking about yesterday, where they come in ready to go. I like the idea of that. What are the benefits of precast concrete for these stairs?
can be installed easily.
Yeah. And the concrete aspect, what's good about the concrete?
Tough.
It's very tough, yes. What else?
Non-combustible.
Non-combustible, like you said, yes, love that. What else? There's something else that it's really good for that other materials might not be so good for.
Acoustic.
What's that?
Acoustic.
Acoustic. Is that what you mean? That is perfect. That exactly is what I was thinking about. Acoustics, yes. If you think about apartment buildings and how heavy-footed people can be in the middle of the night when they're coming home from a party, or how open spaces can create reverberation and acoustic problems in open spaces. Good morning. You are right in the nick of time. All we've done is a recap and we just started the stairs.
Really?
Yep, perfect.
Sorry, I had
you're
supplier
okay.
issues this morning.
Some what?
Supplier issues?
Supplier issues. Yeah, my supplier of coffee didn't get to me on time this morning either. It's a real problem. You alright? Yeah, good on you, Andy. Just give him your chair, Andy, and then take his perhaps. Oh, there you go. That's what he wants. Like, that's my chair. He's not having it. Yeah, fair enough. Nobody wants a warm chair off somebody else. That's not fun. The acoustics of concrete are great. They deaden the sound. They don't vibrate. They don't rattle. You know, when you're walking up open stairs that are a frame, it kind of rattles every step. Yes. So I think that the concrete reinforced precast stairs would be absolutely perfect in this instance. They're very hard wearing, easy maintenance, acoustically brilliant, and deaden all the vibrations and acoustic sounds that might come with having open stairs there. I think that's excellent. Now, I'm hoping that that's what the designer intended. I'm pretty sure it is, but what you'll end up with, I have another piece of paper. I'm just on the back of the other one, it's fine. Oh, thank you, that's very kind. What you'll end up with is the floor slab, and then we want the bottom step to eject with the same riser and going, so the precast stairs will not give you a landing. The slab will be the landing. And it won't give you an upper landing, the slab will be the landing up the top here. So, whoops, nope, yep. So you'll end up with a piece that should look a bit like that, if I'm not mistaken. So this is the upper floor that will be poured in situ, and this is the lower floor that will be poured in situ, and the stairs will either be framed and poured on site or can be precast in. I suspect they'll probably end up framing them up on site and pouring them on site. It might be simpler to get the reinforcing connections. So these ones will have to stick up and down, and then this will have to have equivalent going up and in. So you end up with reinforcing. So you've got the two-way slab reinforcing in the floor, and you need to have reinforcing that goes up and inside. Well, they don't bend like that, but it needs to connect all three places together. Just as well, I'm not a builder.
Oh, so in that case, it would be easier for casting.
It might be, yeah, it might be. But again, that would be up to the engineer and the builder and what suits them best. But definitely concrete.
Mm.
Terrific suggestion. Very good. Terrific. And it does all the work that we want it to do. Soundproofing, structural work, fire rated, easily to maintained, looks good, does the job, never fails. Good old concrete, no wonder we use it so much. For an outside space, the only other alternative really is steel, because timber would deteriorate so fast. We probably wouldn't be able to use it, and I think the noise alone for the steel would be really detrimental to the occupants. Yeah. What about the balustrading and the hand railing? What have we got going on there? So we've got balustrading and hand railing for the stairs, and we also have it for the balconies. So we could probably address both of those at the same time. What do you think we should use for the balustrading for the stairs?
Aesthetically, it doesn't need to be that. It's probably RH shape. Yeah.
It's not prism. Let's get it up a little bit. Just be a bit fancy. Not timber again because of the. But we could probably look at some steel rod. No, probably powder coated.
Oh.
Yeah. So we haven't had an opportunity yet to talk much about steel protection and steel finishing. We'll cover that a lot more next week. But when you've got exposed steel close to the ocean, it's important to protect it from salt-laden air because it rusts more quickly. So painting the steel or powder coating the steel isn't sufficient to protect it under those circumstances. In Stuart Park, it's not too much of an issue. We're enough away from the ocean for that not to be a concern. But in the Class 1 and 10 project, we are quite close to salt water, so we'll have to give it some consideration. But galvanising is typically a good protector of steel if it's close to salt-laden air. The galvanising that comes from the manufacturer isn't often sufficient. You have to enhance that further. So it's called hot dip galvanising. So we'll cover that next week. Remind me if we don't. Where you apply a much thicker zinc coating to the outside to prevent rust getting through. And there are quite a few different products on the market now that also claim to do a similar job. There's a really good product called ZAM, Z-A-M, that I think Stramit produce, that is galvanic protection. It's a really strong salt protectant for steel, so much so that they're using it to build underwater structures. So it's really, really long, it's got good longevity, and it's about the way it's manufactured. Anyway, but we probably don't need to worry about that. So just straightforward powder coating, which is the same surface that aluminium window frame has had applied to it. Actually, I shouldn't say that because it's probably too old to have had that. That's probably just an aluminium finish. I can't see one off the top of my head right now, but just about every window you have, a door in your house now, any steel that you see, any fences that you see, if it's a colour, it's powder coated, which is an applied finish. So a colourful or coloured steel would probably do quite nicely. I've designed and drawn some balustrading that is simply just columns that have a small piece at the bottom and a small piece at the top, and then rods between them. So you've got a bottom piece that's close enough to the nosing to prevent the 125 gap, and then a piece at the top, and they've just got little holes, and it becomes a frame like a ladder. And you put this is just circular rod, just small rods between. Can be quite fashionable. So this is rectangular, and this is rectangular, these are rectangular, but the in-between are circular. So you just have a framed rod, and then you put a handrail right over the top all the way through. How's that sound? Yeah. The other option is, I don't know if you can see it, but on the elevations it looks like they've got a balustrading proposed. Can you see that there?
Yeah.
What does that look like to you guys? See this here? These big square panels?
Glass panel.
Yeah, yeah. Very fashionable these days. Who likes it? Who doesn't like it?
Angela doesn't like it.
No, I don't like it either.
I don't. It doesn't let the breeze in.
It's the breeze. I like the look of it, but it stops the breeze. Yep, yep. And basically to create that, you're looking at, in plan view, a column between each panel. See how there's a slightly darker line between each panel because the glass can't stand up on its own. And then you simply put a channel here, little steel channel, between each of the columns, and you slide the glass in there. And you have to use silicone to glue it, otherwise it will sit on the ground. It would slide down. So in elevation, you've got the columns on either side, and you've got the channel here, and that's the floor. You've got the channel here, and the glass sits up off the ground a bit. The balustrading over the top. So the glass sits a little bit up off the ground, not too far, and a little bit underneath, not too far. So you have to use a glue to hold it in place. So there's a glass silicone that you can buy. So you fill these channels with glass silicone, slide the glass in there, and then just prop it up underneath until it's dried, and then you can take the props out and it just stays there forever. So it can be quite attractive. It does stop the breeze, but it is very fashionable. Your other option is to have steel plates in there, a bit like they use in the car park at the waterfront, where you've got a design etched into it where it's cut through, and that would leave the breeze to be able to come through. It can be a little expensive, and that's powder coated when it's finished as well to give the colour. Or your other option is to repeat this here. But we've already got a directive, I think, by the client that perhaps the glass balustrading is the ideal for the balconies. Would we recommend the same thing for the stairs, or will we opt for something that's a little bit more economical? You can buy perspex instead of glass, that's less expensive.
But they fade up.
Yeah, they go opaque.
What is it, sorry?
It's plastic. You can buy thick plastic, they call it perspex, that looks like glass, but it doesn't stay looking like glass very long. It goes cloudy really quickly. So it's not advisable specifically on the balconies because it gets a lot of sunlight.
That's what they use for car headlights. That's what they
Oh, yeah, right. And you can clean them. You can clean it, but it's hard work. Yeah. You have to sand that section off.
I would think that balustrading for stairs, I guess it doesn't have to be fancy. And probably the glass as they've kind of proposed.
Yeah, for the balconies. Yeah. What do you think? I like the vertical rods for the balustrading because you can't climb them as easily. It's not a ladder.
That's kind of looking a bit scary with kids though.
Oh, the balconies scare me regardless.
Because you can't, it's really hard to obviously like push.
Yeah, you can't get through.
Yeah, you can't.
Yeah, no.
Okay. That's what I was worried about.
The other thing you can do is have clips here with bolts through. That's an option as well, rather than the glue. So the glass comes with a hole pre-drilled, like a car window glass, you know. And it comes pre-drilled. You just have clamps, and they're welded. Oh yeah, it's extremely thick and extremely hard glass. Very unlikely to be able to damage it. So you could look, it's harder to fix the channel to a circular column, but you can do it. So we need it would just be a post, it's not tall enough to be called a column, and then handrail. And then it'll either be channel or bolts. Bolt fixing. The important thing with balustrading is to remember that they have to end, they have to come to a finish. So here where the balcony finishes, here where the balustrading will end, there has to be a resolution there. The glass can't just hang nowhere. So you might be able to put a channel against the blockwork, or you might put a column right there, a little post right there on each end to have the channel finish. And that's usually what happens, is you have a last column a few mil away from the wall, and then the handrail just finishes neatly up against the wall with a tiny little gap. So you put the plate on the handrail and connect it up. Just to keep that in the back of your mind. Don't forget that there's an end to everything. We always tend to draw things in the middle and forget about the edges.
You need to have top rail. It looks like.
Yeah, the top rail. Yeah, it does look only glass, but it's probably just an illusion of the model.
So,
We probably do want something across the top.
okay.
Yeah. It's always nice on a balcony to be able to lean on something. Most commonly, you'll use something that's a little wider than standard RHS or CHS, and it's this oval piece. Although, in this instance, although we probably wouldn't recommend timber handrail might be very attractive in this particular balcony area, but this kind of shape can be quite nice because as steel you can still weld it to the column underneath, but it just gives a little bit of extra surface area. So if these were our columns to make our balustrade, and you could have the channel connected, welded to the side, it's actually quite a neat finish. And it's just called cattle rail. It doesn't look like much, but when it's finished with a powder coated colour, it can be quite attractive. And you can mitre the corners, so if you have to turn a corner, you angle the cut and then change direction. So it's quite flexible. There's enough surface area to be able to have an angle coming off that at almost any degree, and there'll still be enough steel to be able to achieve it. And you could use this for both the stairs and the balconies.
The one thing I have an issue with that is people would often put cups on that, and then that would accidentally.
Yeah, it is tempting to rest things on there, isn't it? As well as your elbow.
So yeah, that'll be.
You're not wrong about that. Yeah. What do you think? Probably has a proper name, not cattle rail, but that's what it's known as, because they use it to make cattle yards.
I think
Guys look it up.
structural engineer or engineer will suggest how wide or how short for the post.
Correct.
To against the people impact.
Correct. And the way it's fixed to the slab, the balcony. So what is probably likely is the reinforcing in the slab beneath it will get lifted up, and this will be welded to it before the concrete, as the concrete's being poured. So if you've got the slab beneath, there's the reinforcing on the bottom of the slab, and then you want the column to be embedded into the concrete. This reinforcing here will get pulled up and welded to the bottom of a plate on the bottom here. So they have a plate on the bottom of this, and that'll get welded to the underside, so it's connected to the reinforcing inside the slab. That's one way. There's lots of different ways. You could simply just embed this into the concrete as well, but reinforcing welding connection keeps it really, really rigid.
I'll find a name for it.
This?
Yeah.
No joy? Yeah, just cattle rail. So, and then you cover that in protectant for when the concrete is wet, the bitumen paint. So that may be one way to do it. Particularly if you don't want to see any of the connections, because the other option is to wait till the concrete is finished and put a small plate, connect that into, just drill a hole into the concrete, use a chemical to connect them. It's called a chemical anchor, or to chem set it. It's very strong glue. So it's 2 parts that you mix together on site and it sets almost immediately. So it's called chem set. It's a chemical anchor. So you could use a chemical anchor and pop that through and then weld the RHS over the top to hide those 2 bolts. So they'd be in there, but it's a bit trickier. So then you would see just a little bit of steel around the outside on your balcony. Doesn't sound too bad, all in all. I do worry about water. You could tile over it, perhaps, so that you couldn't see it. You could hide it with the tile. Might be a bit tricky. Getting down to the details now, aren't we? But that's where we end up. We have to think about what that finish might be like. Do we want to see a plate on top of the slab to connect the balustrading, or do we want that hidden in the concrete, or are we going to cover it up with the flooring later?
I think what I've seen is often I do see the plate.
Yeah.
And then it's probably bolted in.
Yeah, it would be bolted into the slab after the slab is cured. Drill a hole. So it's a fairly small connection because it's not doing a huge amount of work. But like you said, if somebody was to fall into it, you would want it to stay put. It wouldn't be the footing because it's not an isolated, it becomes a system. It's a nest that's then all connected together. So combined, it would do the work of making sure that nobody fell overboard.
Does it also connect to a wall or not?
It can, yes. Yep. So that handrail can go back to another plate on the blockwork and be connected there as well. Yeah. And if it's a round member, then you normally see a round plate, and if it's square, you normally see a square plate. Just make them match. All right, so stairs and balustrade are pretty good. We're looking at a series of RHS and rods for the balustrading, for the uprights, RHS uprights and horizontals, and probably cattle rail for the handrail.
And glass.
Glass infill panels. So you do have to make a bit of a frame for the glass because it can't do any structural work. Keep an eye on here. See just back here where the stairs are, there's more balustrading on the end. Remember that floor is a bit open. So we're looking at balustrading here and here as well. Just to note. So it'll be the same protection. And it'll only be on one side of the stairs because the near side will be connected to the blockwork walls, the stairs themselves. The other thing I meant to mention, got that slide, can I borrow that again?
Oh, yeah.
No, you're right. I might take copies of them.
Yeah, I'm going to photocopy them.
Yeah, cool. The other thing to remember is these steel eyes here will need to be finished on the end as well, otherwise you'll see the ends of them and you don't want water getting in. So it gets flashing or a capping on the end of it. It's just called a barge flashing. And this is actually fascia. On the sides, it gets a barge capping over the edge of the purlins, because the purlins are going to stick out. So on the edge where the purlins end, you'll put a piece of powder coated aluminium sheet. It'll just wrap around the ends so that you can't see the steel anymore. It'll just wrap around. It'll go underneath the roof sheeting, so that over the roof sheeting, so the rain goes over and onto the roof sheeting, and then it'll come down the steel and under. And on this end, it's called a barge flashing, but on the front, it's called a fascia. But it's the same stuff. So it'll just give you a big, thick, white face all the way around the fly roof. And from the ground, that'll look really impressive. Nice, big, wide colour block all the way along.
Is this for the
That was for the fly roof up the top.
Yeah.
And we talked about the construction connection as well this morning. Have a bit of a look at that.
Yeah.
Everybody will get copies of that. Yep. Now, we already talked about the external finish on the ground floor. Did we mention that that's going to be the same external finish for all the blockwork walls all the way up? Yeah. So rendered, scratch coat, painted blockwork walls. Are you all happy with that kind of a finish? It's quite economical. You can pick any colour you want to paint it. Nice light colour, ideally, to keep the building nice and cool. It'll be somewhat shaded by the overhangs of the slabs, so that'll be good.
I just realised that the common area is actually open.
Correct.
Okay.
It's good for breezeways.
Mm.
So it'll need a balustrade.
So one there. And
Yep.
One here.
Correct.
Lisa, what was that again? Rendered.
Scratch coat, concrete, render, paint finish.
It doesn't get too long for me.
It's good, isn't it? Scratch coat is the fancy name of the way the render works, but you could just call it concrete render, paint finish. Scratch coat, yep.
Concrete finish.
Concrete finish, yep, painted. Hard wearing, low maintenance, quite easy to look after, looks good. No mess, no fuss. What about the floor surface for the common area of the slab inside? In this area here between the buildings, between the units. The floor surface here. It's fairly high traffic. It's on the way to people's homes.
If you laminate it.
Yeah? It's quite common, isn't it? Mm.
But it's also kind of gives it a little bit of a more feeling, like I said, a feeling, I don't know, it's like non-industrial or something.
Yeah, a little bit more homey. Yeah.
Laminated?
No, that's a vinyl.
Is it?
Yeah,
Oh, it's a
and
vinyl,
it's internal.
Oh, okay.
Vinyl's an internal surface. Yep.
Right.
So will we match the porcelain tiles from the common area? Not necessarily the same design, but still non-slip. They definitely need to be non-slip. This will get wet in the rain. If it comes in sideways, it'll get some splashes. So the floor surface of the common areas on each floor, non-slip porcelain tiles. That's the one. Yeah, I don't know if it's on the checklist, the floor area out there, because it's not really a compliance thing. It's more aesthetic, isn't it? Mm. Like you said, it's just letting people feel like they're in a nice place.
Non-slip concrete tile.
Porcelain.
Oh.
We once inspected the a unit at, do you know Akoya? They call it like a block of apartments in Penny Bay.
Mm.
And the hallway, it was quite wide,
Mm.
and they put I think a carpet.
Really?
Carpet.
Wow.
I think so.
Gosh.
I'm not sure, but
Yeah.
Yeah. Maybe
And it would have been nice and quiet.
Yeah.
Mm.
Maybe just more.
Mm.
When I lived in Perth, we lived in an apartment block and we also had carpet.
Yeah.
But it's obviously different climate.
Yeah, very different climate. Yep.
Yeah, no.
Wow. And you can get carpets that do outdoors, like carpets that go on boats and things like that. Yeah, but the wear and tear would be really quick. Yeah.
They must need that I like to walk around barefoot.
Darwin.
Yeah.
Someone from Darwin coming.
Yeah.
Just covered it.
I just moved my son out of his flat and it had carpet in the bedrooms and we had to steam clean it 4 times. It's a disaster.
Bad idea.
It's just a bad idea.
Cheap, but it's
Just awful. Yep. Well, it's not good. All right. Excellent. And what about the finish of the stairs?
Definitely have non-slip tape on the end.
Probably need something a little bit more hard-wearing than tape. You can actually get a steel,
Yeah.
aluminium nosing that is non-slip. And then perhaps we could apply the same tile finish because we want to maintain the goings and rises. We don't want the first step to be different and the last step to be different than the in-between steps. So if we apply the same finish to the stairs, then everything will match. We just have to be careful that we still maintain the right to R plus G. But I think if we're going to have cost effectiveness, we might as well have the same tile finish on the stairs and just use the aluminium nosing for the non-slip aspect. So the whole area will need to be non-slip tiles, not nice shiny ones that get really slippery when they're wet. They look beautiful, but very slippery. It's an aluminium angle nosing, and it just has ridges on the top, and it then gets screw fixed to the concrete, and then you butt the porcelain tile up to it.
Would that be the same with the stairs?
Yeah, we've got them, I think. Yeah. A little bit of rubber in them, and then the grid so that you can grip your feet. How's that sound, Andy?
Yeah, all good.
I thought you might say that. All right, excellent. What about inside? What will we finish the walls on the inside with?
I would say render.
What kind of render?
Not sure, but it would have to be something really similar, like to give you like a really smooth finish. What do you think? I think it would be
Inside the house? Inside.
inside.
So this on the inside of the passage area, which is what we were talking about, so I do apologise, we have the same scratch, that's an external surface, so that would be the scratch coat painted render, but I was actually asking about the inside, I didn't mean to jump ahead too quickly. But what Brigitte was saying was absolutely correct. A plaster render. So we want it to look like that, but we don't want to apply a board to the blockwork. We want to apply a render to the concrete. And so it's just called plaster. And it's a very neat finish. It's beautiful.
So it's not scratch coat.
It's not scratch coat. It's white.
It's plaster render.
And it's very fine lime plaster. It finishes white and it'll take paint beautifully. It's very flat finish. If you get a good tradesperson to install it, it looks absolutely brilliant.
It would be pointless to add plaster board. Because it's just like a fun little...
You just bump into it and it's broken. Yep. Plaster's a lot more hard wearing. They do apply an edge right on the corner. There's a small piece of aluminium mesh that you can fix to the wall before you apply the plaster. And the plaster goes over it and there's just a little tiny little aluminium bead that then sticks out, and so that the corners that take a lot of the brunt of bumps and furniture and things like that don't chip away sooner. There's just a little bit of extra reinforcing in the plaster on the corners. So yes, definitely a plaster render inside that then can have a paint finish. And normally for investment properties like this, the paint is just simply a neutral, pale, white or cream colour. The good thing about a good plasterer is they can make what might be a slightly wonky blockwork wall look beautiful. So they'll apply enough render so that the finish is flat. Yeah, they do an excellent job. A good plasterer is worth every penny you pay them. And they'll do the sill as well, so there'll be a nice crisp edge where the window sits in the blockwork. The window is narrower than the blockwork, so there'll be a little edge inside and outside, and it depends on where you place the window as to what the edge will look like. But on the inside, they'll plaster that as well and make a nice crisp edge with the reinforcing the same protection on the window sills and above the doors. What about between the slab above, that is our roof, and the wall connection, where those 2 points meet?
You're going to put a corner?
Yeah, what would we like to do where those two meet?
Are we going to shadow line it or corner?
Well, shadow lines normally only possible if there's a place for the shadow to go, but we've got a concrete slab up there. I think we might even have some examples of different cornices here that we can have a bit of a look at. Where did it go?
Crown molding, I think it's American color.
Oh, yeah.
It's like a bit fancy, yeah.
Yeah. I think
I like
that's
it.
Hey.
Oh, wow.
A few choices there. This is the most common one, the coved cornice here. It just gets glued in place. It's plasterboard. You can see the plaster on the edge there. See how it's got paper all around it, and then that's the plasterboard inside. That's the gypsum plaster, and it's the same stuff as they use to render the walls with. So we could just glue that, and we could have a fancy shape if we wanted to, but most likely we would just get the cove. The other option is simply just to leave it. Render right up to the wall, up to the ceiling. Now we're going to have some battens, probably 100mm battens, 80mm battens, and then that'll be a place to be able to hide the surfaces and put our downlights in, and we'll have plasterboard ceiling lining, and then this would go in after that. So the plasterboard ceiling lining would finish in up here, but it doesn't need to be a perfect notch. It doesn't sit under there, it sits behind, and then you hide that edge with the cornice.
See, that's a thin little edge.
So I've got them.
And that's what that cornice is to hide that gap.
So if we've got our blockwork wall, and you've got the slab above, and you've got plaster on our wall, you can barely see, that'll go right up to the edge, and we'll have a batten, either a deep top hat batten or a C-section, and then the ceiling lining will hang off of that. And then there'll be room for services in there. And then the coving will sit there. And it just covers up that edge there.
So is the name for that thing?
Cornice.
Cornice.
Yeah, I'll label it. And that's the ceiling lining. Yeah, break time.
It's going to happen to me very soon. I didn't have one bit of time.
So it'll just finish in behind there. And you can just glue that cornice in place. I like this one. nice, doesn't it? When you're going around a column like that.
Let's see something.
They speak English, so like it or not, we have to keep up with her.
All right. Ready? Ready already? Ready for more?
I'm never ready.
There's no such thing as ready for this, is there? Excuse me. Come on over, ladies and gents. Smash it.
Where were we? Cornice. So did we decide we'd have cornice? You can pick whichever design you would like. And you can paint that really easily as well. Yay! Coop, coop. So did we agree that plasterboard ceiling lining for inside? We have to have a more waterproof option in the bathroom. You can't have plasterboard ceiling lining in wet areas. So we're going to need to have a different ceiling lining. We can have the same plasterboard that the cornice is made out of in the bedrooms and living areas and even the kitchen, but you can't have plasterboard ceiling lining in wet areas because the plasterboard will perish. It gets full of water too easily. Can anybody suggest an alternative ceiling lining in the wet areas that won't absorb water as easily as plasterboard might?
Fibro sheeting.
CFC sheeting, absolutely. So compressed fibre cement sheet ceiling linings in the bathroom and the laundry. You can get a product made by CSR that is plasterboard, but it is more water resistant, so there's some water resistance in the paper on the outside. It's called AquaCheck. So that could perhaps be an alternative. But considering we've got a concrete slab, we may as well have CFC lining as well.
What is it? Compressed fibre?
Compressed fibre cement sheet in the wet areas. So the bathroom and the laundry. Not so bad in the laundry, but definitely the bathroom where showers and steam and...
Is it a standard or is it?
Yep.
I'm pretty sure that our
Yours doesn't have it?
bathroom ceiling.
Plasterboard?
Plasterboard. It looks like it anyway.
It does all look the same, yeah. So you paint the CFC the same as you paint plasterboard and it looks the same in the end. If you knock on it, it'll sound more like concrete than the dull thud of plasterboard. But it is hard to tell depending on what it's fixed to. But you screw that to battens the same as you would plasterboard. Plasterboard absorbs water more and then it becomes heavy and it sags and then gives way. So that takes us to the ceiling and all the inside. But what about the balcony?
You can use blue plasterboard for the balcony.
You can. Do we want to? When you say blue plasterboard, do you mean the AquaCheck that I'm talking about?
Yeah.
Some certifiers won't allow it.
Really?
Because the rain really does get there.
Okay.
Yeah.
Yep. With my stepdad, we did put the blue.
Houses, did you say?
Yeah.
Yeah, so there's a 900 overhang that coves down to help prevent the rain from getting up underneath. Whereas with ours, we don't actually have that. We'd be plasterboarding right to the edge, so a certifier wouldn't permit that. What are we going to do with our balcony lining? So far we're looking at raw concrete.
Are we thinking of painting it?
We could paint the concrete. What about the services? We're going to have any lights or fans out on the balcony?
Why?
Sometimes to prevent having to put services in the concrete, they put the lights and the fans on the walls. But this is a big balcony.
I think ceiling fan would be nice.
Couple even. We could have a bit of fun.
Yeah, usually they do put on the wall, don't they, like the lighting for balcony.
They do sometimes. We don't have much wall space because we've got doors.
So yeah, maybe.
So if we battened it and lined it, we could have lights and fans in the ceiling. So battening it out is the same as inside, but what about the lining? What might we line it with? Could have a bit of fun. It doesn't have to be too boring.
I'm just thinking, we were talking about this innovative Australian product, and I think, is it the same one? No, maybe I'm not talking about the same thing. But you can have it like in different heaps of different colours and stuff.
Yeah, right.
Sometimes like a timber look. I've seen like a lot of, some verandas in houses actually have got like a really brown coloured, I don't know, that doesn't look like natural timber to me. I'm not sure what the material is.
I don't know either. But you can use ply. So the underside of the basketball court gazebos is ply, the lining. Can be quite nice. You have to maintain it a little bit. It does get a bit of exposure to the... Did you eat something?
I did.
You did? Your stomach hasn't noticed.
Yeah, I haven't had
But it's still quite exposed towards the outside. So the ply might get a little bit perished quite quickly. And the tricky part is how do you finish where the edge of the concrete is and the edge of the lining is? How do you finish that? Because there'll be a gap where the battens are. So that'll be tricky.
Maybe, I was just thinking that to use any timber product will be kind of out of, like, wherever
no other timber anywhere else.
That's why it will be kind of like, all
agreed.
Weird, basically.
That would be weird.
So I would go with maybe even the same sheeting.
CFC. If you're going to line it with anything, it would probably be CFC, yep.
This is on the balcony.
The balcony ceiling lining. Yeah, batten it and use CFC. And then the last batten could be SHS, and you could paint it, and then it would look nice at the ends. And you could flash that to prevent water from getting in. Now I've got this funny phenomenon here. I don't know if you can see it. So we've got a mid-height blockwork wall here, out on the slab overhang. So there's a bit of protection there for maintenance people who need to come out to the air conditioner. But there's this funny hatch on the drawing that lines up with part in the elevation just here, just next to the lift. Can you see that there?
Yeah.
What's that, do you think? An elevation? Just here. And it's here as well. Oh, excuse me. Move the desk instead of moving my chair. So, really lightweight aluminium extrusions that have got a colour on them can be excellent for just covering up big places. So you can use something like a Hunter Douglas product that just is slats, big slats. Now I'm not recommending this for our balcony, but just big vertical slats on the outside of the building. They allow a breeze to penetrate. These are all ceilings. They allow a breeze to penetrate, but they also shield the view. Which can be really quite a nice feature. have a look a bit through those. But I would perhaps recommend for these vertical slats a lightweight aluminium extrusion that can be powder coated with a colour.
So powder coated
Aluminium. Extrusion. EXTRUSION, I think. Hunter Douglas are pretty good for shade. We'll use those as well, perhaps, and I don't know if you've really picked up on it completely, but there's this cantilever steel awning up on the 3rd floor. Big shade that just sticks right out. So cantilever is a phenomenon, a construction phenomenon, where you have a support back from the edge and the bit that hangs over has no support on the other side. So it's cantilevered, C-A-N-T-I, cantilevered, L-E-V-E-R. So a cantilever steel awning. And it's right up on the top floor. This one here. So it's not a steel sheet awning where it's impervious. It's kind of awning where there's holes between them, like a pergola might be on the ground floor of a Class 1 and 10 building. So I'm thinking maybe something like this Hunter Douglas product might be the same sort of product that you would put. So these solid lines are the supports, and these dotted lines are the awning material going perpendicular to it.
So use aluminium.
Aluminium as well, very light, yeah. Later in the year you'll work out how to connect the steel to the concrete. But what I predict would be that the thicker slab, the 250mm slab that we were proposing, would take some of that steel into it, embedded in there and welded to the mesh, the reinforcing. So there would be RHS welded back into the slab to give that structure. And then, so it usually goes twice the length that sticks out. So you've got 2 times the length in the slab than you have sticking out. And then that will take the load of the lightweight aluminium frame on the top. So we've got the edge of the slab itself. And then the reinforced that would actually go back inside. And there would be, I think there's 4 of them. And then the aluminium slats would sit over the top. So that's the edge of the slab, and it comes back this way. And the reinforced, the steel that sticks out, that you can see sticking out, actually has to go into the slab. And it's 2/3 in, 1/3 out to be able to achieve the structural stability that you need. And then it would get welded in between the 2 courses of reinforcing. And then you could simply weld or screw fix or plate and screw fix some slats or panels. You can get those angled. They look like a Z, a bit like that. You know, the shade slats that go across, they're made of steel. And then you simply just have a plate with a bolt through to connect it to the steel, something like that.
It's quite long embedment, hey, 2/3.
Yeah, it has to be a fair way for cantilever, especially that high up under those wind loading conditions. You can just imagine if the wind got up underneath that awning, it would really wobble about, so you'd like it to be nice and sturdy. It's very light material on top, it's not doing any structural work, it's just that wind load that it's under. Or you could have a small aluminium slat, just a square. There's plenty of products in there that you could use, coloured, lightweight.
And is it for provide shade?
A little bit of shade, a little bit of differentiation on the aesthetic at the facade, just to make it look good. It's nice and high, draws your eye up, makes the building feel thin. So that appears to be something that they're looking for in the design. You can just make it out in elevation. It's not easy to see.
With the hole for the embedment, is that already pre-cast?
It'll get cast into the slab before it gets poured.
Okay.
Where is it? Where's the front? Here. See that big bit sticking out on its own? It's not concrete.
Yeah. I think I thought it was just one thing you need to cast.
Would it be cast in?
Right up the top. Yeah, can you see it? Yeah, it's really hard to see. And there it is down on the opposite. Oh, what did you say there, one?
So would it be cast in situ or? Yeah.
Correct.
Okay.
It'll sit between the two fabric mesh reinforcing and get welded to them, and then they pour the concrete over the top.
Right.
The reinforcing in the slab, and it'd be welded top and bottom, and then protruded back in and covered in bituminous paint to protect it from the wet concrete, and then it would just stick right out. And you could have it finished in a variety of different ways. So you've got a piece of flat square steel coming out there now, big piece of square cube steel. You could finish it in multiple ways, but probably what I imagine would happen is they do something here where they just cut it back a little bit underneath, chamfer that, chamfered finish. Or you could do just a plumb cut. So it would be straight, so you could just end it, or you can cut it back this way a little bit. Cut that back.
No cap plate?
Yeah, it has to have a cap on the end.
Okay.
All sealed up.
Square hollow section.
I would imagine so. And again, powder coated and painted the colour that you like. Not painted, powder coated the finished colour that you'd like. And perhaps it might be a dark accent, maybe a grey or a black, because the rest of the building is going to be quite pale. So you could have a feature of the vertical cladding on the fly roof that could be a darker colour, and then this could be the same dark colour or even darker. Just an accent. I'm not saying, pink accent, but like a neutral accent. Don't get too crazy. Yeah. Thank you for this paper. Precisely like that. You've spotted it beautifully. That new CNC building that we were talking about the other day that IMP designed has got Hunter Douglas awnings added to it as well. You'll see them in the pictures there when you come across it. And I think the front of the convention centre is Hunter Douglas products as well.
Is it really expensive?
No, not extraordinarily so. It's just, it has an expense, but it's not too bad.
It looks like it could be.
Yeah.
It's probably because it's good marketing.
Yeah.
It's
Yeah.
really fancy.
Yeah. So that gives us something to cover up the air conditioners on this side. And they've got the same thing on the other side, but I think that's the edge of the, what have we got here on this elevation? So that's the lift there. What have we got on the other side? Is that the balcony?
That's a balcony for the bedroom.
Yeah. Oh, is it?
Is it? Oh.
No, I think it's just this area here.
Oh, we're on the, sorry, I thought we were on the
Yeah, no, we've just done that area there.
Okay, yeah.
But we've got more over here. I'm just looking at this. What's that? That's here, isn't it? Oh, it is. You're right. It's just the balustrade and then it's open. So there's only aluminium on the one side. Quite right. Thanks, Nick. Sharon, keep calling Nicole. And we've got air conditionings exposed on elevation 2. It's the back, isn't it?
I know the property, like I just googled it.
Oh, it's just this here. That's the air conditioners that we can see. So you can't see them from this side, but you can still see them from that side, which is okay. Because it's the rear, it's not too big a drama. It's mostly visible from the road and the sides are covered now too. This one here is behind the blockwork wall, so that's not too bad. And there'll be a little bit of balustrading here as well. Have they got the glass on that side? Yes. So glass balustrading here and here as well. All right, we're doing well. So we talked a lot about the ground floor earlier with the carport space and the car park space and the blockwork walls that are doing structural work, but there is actually more structure on the ground floor that's actually quite difficult to see in plan view. But if we look at the site, if we look at it in plan view from here, what do we see? Excuse me. What's on this drawing that has a relationship with this drawing? Yeah, well done. What is it?
So the bin enclosure, isn't it? Shading for the car park. It looks like flat concrete.
It looks like concrete in that sketch, but it's not concrete. Where's that 3D though? That's quite a good image of it. Here it is here. Oops. So we've got this funny little shape here, and then we've got roof. And then on the other side, can we see it? We've got a little bit here. So it's additional shade beyond the main perimeter of the building, closer to the boundary, and we talked about the perimeter boundary and its relationship with that the other day. And you can see by this hatching that they're looking for a particular roof finish. What does that hatching refer to?
Metal sheeting.
Yeah, metal sheeting. So you're probably looking at column and beam and purlin structure on the ground floor for the external shade, and then roof sheeting. And then I think this is a feature wall, like a nice stone finish or sandstone finish wall, just as a feature near the entrance. You can see it in this plan here. It just pops up in plan view, and it's got a different hatch. You can get some really nice feature tiles that, like bookend slate or sandstone look tiles that you can fix to blockwork to make it look really attractive. And that might be a place where if the apartment complex has a name, or you could just put the street address on there so that people coming by can find it easily. I don't think we've got a name per se for our apartment complex, but that's quite common. So that might be a location where you can fix lettering for the address. can see it just pops up out behind, just near the bin enclosure there. So strip footing, blockwork wall, and then column, beam and purlin with roof cladding for the carport shade.
Did we discuss that we might not have the roof over the bin enclosure?
Yeah, we just need to go. Yep. While we're doing our application, we're suggesting that we get approval to go up to the 0 lot line with the shade.
Okay.
Yep, blockwork feature wall with a decorative tile finish. Yep. So we've got a feature wall with a strip footing. You writing this down, Andy? You're okay? You have it, well done. So a feature wall with a strip footing, it'll have its own strip footing. Blockwork, reinforced concrete. And a feature tile. So the client can pick that out. And you can make a note there, that's for the address perhaps. Lots of parts to a big building, isn't there?
Question.
Just
popped in my head. I know I'll forget it. Would they need to have like letter boxes, or they just have like a?
Yeah, no, they would have letter boxes. Yeah, absolutely. Probably right there.
Yeah.
Yeah. Yep. So, Despina's just pointing out a little wall here. Perhaps that might be a place where the letter boxes can go, so that you can collect the mail on the way home. Needs to be convenient to the front of the block for the mailman to come and deliver it. And this is a gate that then comes across. See that there? So probably looking at an aluminium gate as well. Be one of those ones where you have a press button so it opens automatically. Automatic gate, and there might be it'll be connected hardwired to the power to get the power source that it needs. Alright, so while we're on the ground floor, just briefly, we want to touch on the doors. So there's a gate by where the bin enclosure and now the mailboxes will go. So that would be an aluminium security gate as well, the same as the front gate. And then there's also a couple of doors into the stairway area. That would probably be similar construction, so steel mesh or steel aluminium framed or mesh doors. So not solid timber core doors, they would be ventilated. So you can get a steel frame, it's just a frame, and you can put the mesh inside. It's like a perforated aluminium sheet. So it's a single sheet of aluminium with all millions and millions of holes punched in it. So you can use that, or you can have aluminium slats in the door as well, a bit like the balustrading or the aluminium screening that we've got.
They would still in the storage.
No, I'd say that would be a solid timber core doors for the storage. Yeah, so that you can't see inside. You don't want people to be able to see what your belongings are. But for the access, you want to be able to see if there's a person on the other side, so you don't open it onto them by mistake. But it also just lets a bit of ventilation through. And it can be open above and below and things. It doesn't need to be closed off.
So only for the access to the
These two here and this one here. Aluminium powder coated security gates. And this part here might have the whole space enclosed right up to the underside of the slab, so people can't climb over and get in. So we have this lovely big gate at the front, but if we only have a low door here, people could just jump over. And they're away from the street, there's no passive surveillance available there. So this area here might actually be that perforated sheet for the whole wall. It's open enough for breezes to still go through and for visual inspection if you need it, but you can't actually get access unless you've got the key to get in. On just this spot here. And there, I guess, too. So rather than having framed cladding or blockwork in that place, it can just be perforated steel mesh. So you make a frame around the whole space and perhaps across the top of the header at 2.1 high, and then you weld the perforated aluminium sheet in the hole. So it's just a frame.
Like,
Okay, I'll put this clean. We're good.
And I would say that this entry also needs power. That's something that we should note.
Yeah.
Just for the,
Yeah, for the security.
Yeah,
Mm.
and also
The intercom. Mm. Yeah, lighting, definitely.
and
Yep.
also security door.
Mm.
Yeah.
Yep. So underneath the transfer slab, between this carport wall here and the lift wall, you just simply add RHS powder-coated frames and then sit the door frame inside that and insert weld-in perforated sheet in all the gaps.
I think I've seen those kind of.
It's quite common, yeah.
I'm not sure.
No, just about all common areas have them. But solid timber core doors for the storage areas. So normally inside doors are quite light, but timber doors that you use on the outside walls are solid timber. They're very heavy. Solid core. So C-O-R-E, the core of the timber is solid. Solid timber core doors, not hollow core doors like inside.
So this too can be
They
aluminium.
just be aluminium gates. Yep, quite right. So the lift will be provided by a lift manufacturer, but perhaps you might like to do a little bit of research about which lift manufacturer is available here in Australia, who delivers to Darwin. We don't have a lift manufacturer in Darwin. It would have to be brought in from somewhere else and installed, so they would come here and install it for us. For the approximate size that we've allocated, how many people can that transport? Give a bit of an idea of what that's about. Don't feel like you have to go into too much detail, but maybe do a little bit of research about what kind of lift you think might be suitable.
Sorry, I just wanted to ask about that being enclosure door. So would that be mesh along the perforated mesh door as well?
I think once you start with a style, you might as well stick with it.
And yeah, because it doesn't have to be security there.
No, it doesn't, but we're matching, I suppose, then, because you could just use a standard pull fence and top and bottom like our balustrading.
Also, isn't it all the way up?
Not for the bin enclosure, it'll just be low level, just a gate, yeah.
Okay.
And that perforated aluminium mesh is good for hiding the view. You don't really want to look at bins unless you absolutely have to. So it'd just be 1.8 high.
The 18 toilet is same aluminum.
No, it'll be a timber door for the little room as well, I think. But it'll have to have lift-off hinges. Excellent. So while we're talking doors, what sort of doors would we have for the sole occupancy units?
That same four doors and closing, automatically closing.
Yeah, excellent. So self-closing timber solid core doors for the sole occupancy units, and we'll give them a mesh screen door as well.
Yeah, maybe if it's all open.
So sometimes in the tropics we put the screen door on the inside. Has anybody ever lived in a house where the screen door is on the inside instead of the outside?
Yeah, and I'm wondering why.
That's so you can open the big door out and then keep the screen door shut. Whereas if it's the other way around, you have to open the big door in, and it can often be sitting in your path of travel. So normally when a door opens, you close it behind you. But in the tropics, you like to leave the heavy door open and keep the screen door shut. Now, that's not necessarily going to be an option for us. We've got these fire doors that have to be closed all the time, so that is going to be a bit tricky. But if perhaps we had the screen door on the outside, we could hold the door open to get the breeze if we wanted to while we were home. Don't really know whether that's wise or not. What do you think? They do have to be fire doors, and they do have to have closers on them so that when you let them go, they close behind you. But you can prop them open in your own home when you're home. So they're not going to open out, even though you would imagine that a fire door in a commercial building would have to open out. We are not going to open these doors out because they would be opening into the path of travel to the exit, and that would be worse. So they do open in as they're shown on the drawings. They wouldn't open out. So you could still have a screen door on the outside, but then that would open out into the path of travel, so perhaps not. So maybe no screens. That's a shame. No screens. No. Sorry.
So instead of
The only way we could have screens is if we brought the doors back and left room for the screens inside the house, which is not a crazy idea, but we haven't done that on this design, so we won't.
so it's not allowed.
No, I don't see how we could facilitate screens because these are fire doors and fire walls, and they have to be closed in the case of a fire. So if you propped it open, that would be a bad thing. And if you had the screen on the outside, because you have to have them go opposite directions, you can't have both doors opening the same way, the screen would open into the path of travel out in the passageway.
One of my friends, he lives in the Steel Park, Queen Street.
Yeah.
The apartment,
He has a fly screen door open now.
Yeah.
And the main entry door inside.
Yeah. Yeah. That's most typical, and if we were achieving that, and the certifier might permit it and say, under these circumstances, a screen door is suitable, but we're probably not likely to ask.
So we will just have
the main solid core door, yep, and it'll open in and it'll have a self-closing mechanism. What about the other doors inside the house?
Well, they don't have to be solid core starters.
No, they don't. They could just be lightweight, hollow timber core doors.
And they don't need to be self-closing.
No, they don't. And then standard internal hardware. So we've got lots of door handles on the windowsill around the corner. Take your pick of any of the public access hardware. And what about these other fancy doors out to the balcony? So there'll be aluminium framed glass sliding doors. And they can be powder coated and coloured the same as the window frames. What about the floor finish? Did we discuss that yet? Inside?
Inside, no, not inside.
We haven't said, have we?
But I'm pretty sure that the client may have suggested tiles.
I think they did. The porcelain tiles? Yep. So non-slip porcelain tiles in the bathroom and the laundry. And just standard porcelain tiles everywhere else. I think that's fair. What about the skirting? How will we deal with the connection between the floor and the wall?
Super tile, you either use tile or you just like a timber skirting. I personally like timber over tile.
I do too.
Tiles is a bit awkward.
But I have it at my house, and some of them are popped out. I don't know if they were done correctly or not, but some of them are popping out because of timber. So now I'm like, should have done tiles. Timber.
So the good thing about skirting is a bit like the cornice where the ceiling lining comes up to the wall and you cover it up, this end here. It doesn't have to be perfect. When you've got timber flooring or carpet flooring and it comes up to the wall, you can cover it up with a timber skirting so that this little raggedy end doesn't look untidy. But tiles are very neat. Very neat. You cut them perfectly. And it's excellent. So you could go without skirting entirely.
I prefer skirting.
Everybody's used to skirting, but you can go without, and it's not weird. So skirting typically catches dust on the top edge. That's a common thing. And then, of course, you've got to decide how are you going to finish whatever skirting you've got. But you can have the option to go without. So I'll leave that up to you. You can choose keep skirting or don't keep skirting. And option 1 is a small piece of the same tile that you're using, normally just a 50mm high cut off of the tile. But porcelain tiles are 10mm thick, which is quite significant. And like I said, you only get a small veneer of porcelain and the base is concrete. So when you cut that and then stand it up, you'd be able to see that edge, the concrete and the porcelain, so then you would have to paint that. So the top edge of the skirting would have to be painted if you were using the tiles. Perfectly fine, that happens all the time. Looks really good. Or you can do this with timber.
Like skirting is just good for protection, like if you're moving
furniture and chairs and things. Yep. Vacuuming up against it, all that sort of stuff. Yep, there's lots of benefits for skirting, so you may choose timber, tile, or none. I don't mind. You cannot go wrong. Have we exhausted all the construction? Surely we've come to the end. No. I can't think of anything else. Oh, the windows. We haven't talked about the windows. Sorry, yes, you're quite right. So powder-coated aluminium frame windows. and then mostly louvers, I think, if I'm not mistaken. There's one set of sliders right at the front. So the bedroom windows either side of the main balconies on the front elevation look like they're slider windows.
And the laundry as well? That'll be sliders.
Yeah, probably. Oh, no, you can have louvers in the laundry.
Louvers.
I'm just trying to see on the elevation what the design intent might be. Let's have a look. All louvers. Except for the 2 bedrooms on the front elevation. They're sliding. Everything else is louvers. And we'll recommend a maximum of 600 millimetre wide bays. You can see there's little mullions specified in between the louver bays on the windows. And they're quite good, they're high set, so they'll be easily shaded by the overhang.
Why?
600?
Yeah. What is it? 600 mil?
Bays, B-A-Y. It's a bay.
Okay.
Excellent. Whew. Now, what about the services? We haven't really talked too much about the services of this building. We already know that we need a fire hydrant system through, don't we? So there'll need to be a way to connect to all of that. And we've talked about the air conditioning. What are we having for the air conditioning again? And so we'll have independent ones. We talked a bit about combining the outside unit for a couple. So 2 bedrooms, for example, might be able to share the same condenser outside and then just have an independent unit on the inside. Does everybody know what a split system air conditioner looks like? No? So inside it's just a big white box quite high up on the wall, and you have a remote control. You press the temperature that you want and the fan speed that you want, and the cold air comes out. And then there are pipes through the walls, and they go to a box outside with a big fan inside, and refrigeration, like a refrigerator, has a motor inside that creates cold air, and you use electricity to run it.
The most common air kind around.
Yeah. The other option is where you have the box and the outlet connected together, and they sit in the wall or the window, half in and half out, and they're just called a box air conditioner. So a split system is called a split system because the system is split in 2. You get the inside unit and the outside unit up to 10 metres away. But the box air conditioners, the refrigerant part that sits on the outside and the condenser, the part that sits on the inside, are all connected together, and they just sit in a frame. They can be a bit noisy because the generator, the motor is right there, whereas with a split system, the motor is further away, which is nice, so all you hear is the breeze. What we're proposing is that we use those air conditioners for this project so that we don't have to worry about ducted systems. We don't have to have as high a walling system to cater for it, and we don't have to have a system that's all interconnected. So what we'll need to do is research how big the air conditioners need to be for the room sizes that they are servicing, how many horsepowers, how many kilowatts we need to supply in size. So you'll have one air conditioner perhaps that will service the kitchen, dining, living combined rooms, so that'll be quite significant size, and then independent for the bedrooms. So there's 3 bedrooms in these double-sided units, and then it's just 2 bedrooms in unit 1, 3 and 5. We don't typically put air conditioners in laundries or bathrooms or storerooms or anything like that, so it'll just be the bedrooms and then the main combined living areas. So investigate how many kilowatts the size air conditioners would need to be for approximately that size. The manufacturers' websites are pretty good for that, and Power and Water have an excellent website with a lot of information about what size air conditioners are good for what size rooms. We have quite energy efficient construction, so they'll be quite cost effective. What other services might we want to supply to our occupants?
Power?
Yeah, electricity. So how will electricity reach them? Maybe you want to guess about that? Joanne, you want to jump in? Electricity. How will electricity reach our occupants?
There's a main in the street.
Yeah. Have a look and see if we've got our site plan.
It's
Yeah. We got.
On the easement.
Is there an easement?
I think there is.
No, it's behind us, but that's sewer easement.
That's the goal before you dig map, isn't it?
Yeah, yeah. Did we do that already?
We did. We've got.
Yeah, we did.
Yeah, yeah. So I'm going to use electricity in my unit. I'm in Unit 1, and I want a bill that's just mine. How do I make sure I get a bill for just my electricity use?
It has to be like something that's kind of,
Yeah?
power switch or
Kind of?
No.
Well, yeah, yeah. So there is a switchboard. That doesn't give me a bill, but there is a switchboard.
Like a separator or something. Is it called?
Kind of. Anybody else have a clue? A bit of an idea? So, in your own home, where you live by yourself, there's a meter box. So you would want a separate meter for every sole occupancy unit that counts the electricity usage from that point. So down here somewhere, there'll need to be a place where the electricity that comes into the site goes to a location where there are 9 meters, all with their own counter. And then the electricity will get separated off, and all the wires from that counter will go to that unit via conduits up through the walls and through the floors. Separate meters for every unit. Inside each unit, you have a switchboard that you mentioned, which is where the electricity comes to first from that meter box. So it'll be the wire that comes from the meter box will go to the switchboard, and then from there there'll be fuses, and the electricity will come through that and go to the different outlets. So there might be all the power switches on one circuit, all the fans and lights on another circuit. The washing machine and the dryer will be on a separate circuit because they're normally bigger wires, particularly the dryer. It needs more electricity than a light or a standard power point might need. And there'll be another circuit for the air conditioner that needs a bigger wire. So typically air conditioning and dryer circuits are 15 amp wire, and standard general purpose outlets, GPOs, are 10 amp wire. So the fuses and the wires are slightly different for the different appliances that they're servicing.
Is it a requirement to have a switchboard in each unit? Because I'm pretty sure that it's not.
And the reason it's a requirement is because if there's a fault, the electricity needs to be cut soon enough to save human life. So before safety switches were invented, and I think they're an Australian invention, before safety switches were invented, electricity didn't stop if there was a fault. So I, as a young person, connected 2 extension cords together when I had just come out of the bathroom. So I was dripping wet, and the water got in between the electricity cords, and it was connected to the power point, and I was electrocuted. So the electricity didn't cease. There was no safety switches 40 years ago, so it just kept coming. And thankfully, my mum turned the power point off in time for me to still be here talking to you. But safety switches would have cut the electricity much quicker. Within even the quickest instance you could possibly ever, it is instantaneous. So it's really important to have switchboards. Now it can be very tempting. They can be really annoying, those switchboards, when they do that, because you don't want the electricity to trip. So you can be tempted to go and just turn it back on again. But what you've actually done is re-instigated a fault that might have tripped for a good reason. Sometimes we overload the circuit. So I just talked about the amount of electricity that's supplied. So if I've got a hairdryer, a toaster, the kettle, a toaster, flat iron, and somebody else, and we're all plugged into the same, all actively creating heat and energy and cooking, and hair dryers are hot and things. We're using a lot of electricity. We might overload the circuit, use too much electricity, and flick the switch. So that lets us know we've done the wrong thing. We can unplug a few things and turn it back on again safely. That's not too big a drama. But I know of people who aren't overloading the circuit. It triggers because there's a fault in the wiring in the walls, and they stand there with their finger on it and hold it until it stays there. Hugely dangerous. So switchboards can be dangerous to access, and I have pulled them apart and things and seen wires that have come undone and fixed them and things like that, but you're not supposed to touch any of those things. So if in doubt, call an electrician. But they're available, they are in every unit, yes. Yeah. So that's a safety switch. And in the old days, they didn't have the switch, they just had ceramic fuses with wire, and the idea was if you overloaded, the fuse would blow, and then you could just replace the fuse and stop doing whatever it is that made the problem. But because people got annoyed with fuses, they would increase the wire, they would use nails, they would put bits of metal in there and things to create a stronger circuit so it didn't blow. But then, of course, you end up with the kind of heat build-up in electricity that burns your house down. So it's better the way it is. It's much better the way it is. I'm very grateful for safety switches. Yeah.
Yeah, safety switches and everything, even in the what is it? Double adapters and all that?
Yeah.
And even
Yeah.
the switchboards?
Yeah. Override switch.
Just a question, nothing to do with building, but when you forget your iron on, is it going to trip out eventually?
No, because it's the same amount of electricity consistently. As long as the house didn't burn down because of the iron, it would just be there when you got home.
That's my biggest fear. Did I turn the iron
on? So do you want to know what the remedy for that is? It's really simple. Bring the iron with you. It's that simple. If you're ever worried you forgot to put your hair straightener off or your iron, just bring it with you in the car. Because then every time you think, did I turn the iron off? You can go, oh, it's just right there.
Oh my God.
That's because I kind of try to remember that
Yes.
I turned the switch off.
Yes.
That I just like, okay, I remember this now.
And then you say to yourself, am I just remembering what I did yesterday?
Yeah.
Or am I remembering today? Just bring it with you.
Or the other.
Just bring it with you. The cat, the iron, the dog, whatever's worried. Whatever you're worried about, just bring it in the car. It's fine. Yeah, I would love that. Pets allowed. Yeah, I get you.
No,
It just chews through electricity. Irons are expensive to run. So we've got electricity. We've got what? What else? We've got fire water. We've got a hydrant. What else do we want?
What about some occupancy water?
Yeah, we want actual water, don't we?
Occupancy water.
Occupancy water, yeah, potable it's called. P-O-T-A-B-L-E, potable water. Fire hydrant water is typically just as good quality here. We're extremely fortunate to have such amazing water in Australia. We take it for granted every day. So our fire water is drinkable water. How extraordinary is that? But you're not supposed to drink it, just in case.
Because it's not probably tested.
No, it's not regulated like our town water is. But potable water comes from a reservoir and it's tested and made sure that it's safe to drink. So we don't have to worry about it. We just turn the tap on and fill up our glass and drink it happily. We're very, very fortunate. We want our potable water, so cold water comes in. Do we get hot water from the council? No. Is the hot water tap connected to some big hot water system somewhere over on the other side of town?
No.
No. What will we do about hot water?
In the unit.
Yeah, we'll have a hot water system inside the unit, in probably the bathroom, in a cupboard or in the laundry. Do we have laundries? We do, don't we? In the laundry, I expect, in the laundry cupboard. So it'll be up to you to research how many litres it needs to be for a family that will typically live in an apartment this size.
Litres is most common. Okay.
So the cold water goes into the hot water, and there's an element in there like your kettle, and it has a thermostat, and it recognises when the temperature of the water is dropped, and it kicks in and heats it back up again. And you can pick a hot water system that allows you to determine what that temperature is. It doesn't need to be very hot. Most people mix cold water with what they use the hot water tap for. So you might as well just have cooler hot water. 65 degrees is plenty. Can't stick your hands in much hotter than that.
Sorry, but in normal circumstances, it's not us who kind of say that we have to have it. It's electrician or...
Yeah, the electrician will install it for you. Yeah, it's on the electrical layout, absolutely. So we're just proposing some services. So an internal electric hot water system. We're not really in a position to have solar heated hot water. That would be lovely, but we don't have that set up. If you're particularly invested in sustainable service provision of apartment buildings, I would definitely applaud some further research into systems where you take the hot air from a ducted HVAC system and use that heat to generate hot water. There are some terrific systems out there if you're interested in any of those. But independent little hot water systems is fine.
That's home in Australia because we gets quite cold there.
Yeah.
To like -30.
Yeah.
There
That's
are
cold.
central hot water pipes. You can see them because the
Everything
snow
melt next to them.
Yeah,
Wow.
you can see where they go. Yeah.
Wow. So you have to protect those pipes with a lagging, like that foam stuff that we were looking at, to keep that temperature consistent. If it's cold, you want it to stay cold. If it's hot, you want it to stay hot. So the air conditioning pipes get lagging, and the hot water and cold water pipes get protected as well. So typically cold water pipes are a flexible tube, and the hot water as well. And typically you can have a valve that will also prevent and have the mixer, but prevent the water from coming through if it's not hot enough yet. It's a new system where if you've got hot water and you know the water that's still in the pipe is going to be cold, you can divert that back to the tank and then only get the water that's hot. So when you turn the tap on, nothing happens immediately, but that's that cold water that was sitting in the pipe from before that's gone cold. It diverts away back into the tank to save that little bit of water, and then you just get the hot that comes through. Yeah, it's kind of cool. All right, so we've got water going to all the sinks and the toilet and the hand basins. And we've got hot water coming in from the hot water system to the same places, except for the toilet. We don't need hot water in the toilet. Now, you do provide hot and cold water for the washing machine location, but most washing machines these days, the front loaders have their own hot water element in them, so they only take cold and then they heat the water up themselves. But a top loader takes hot and cold on its own. So you'd have to have the hot and cold water for the washing machine and then electricity for that as well. So we've got power, water, air conditioning. What else? And we've got fire. That's 4 things. What else do we want? Plumbing away. So we kind of take care of that. Yeah, I'm thinking about stuff coming in.
Maybe
utilities.
Maybe it's a bit too fancy, but gas stove.
Oh, okay. So reticulated gas can be available. Some of the main Esplanade Street in the CBD has reticulated gas, and some areas out towards the back of Berrima have reticulated gas as well. But the vast majority of Darwin does not have council piped gas. If you want gas, you have to have a cylinder, a bottle of gas brought in, and then you pipe the gas to the appliance from there. So we don't really have an opportunity for reticulated gas or really an opportunity for bottled gas. So all our appliances are going to have to be electricity. It's a good question though.
Say internet?
There you go.
TV?
Absolutely. So the NBN brings 3 different attributes. What does it bring?
Phone.
Yep.
Internet.
Yep.
And what's the other one?
You said it? Yeah,
TV.
digital TV.
Yeah.
Yep. All on the same line. So we need to bring, it's similar to the electricity where we want it independently metered. You want your own internet connection. You don't want to share your internet connection with the house next door. So the NBN will be a separate box for each unit. So
So there will be 9 boxes?
Yep.
Wow.
Yep. And so the NBN will come in probably as a single box and then go off into 9 connections at the units, and you'll have a small box inside. And then from inside, the internet NBN needs to fan out. It doesn't go as a daisy chain. It fans out from the single port like the circuits for the electricity do. We don't need to have a circuit for the NBN, but it fans out to each of the different locations, and then the way it's installed determines which feed you get from it, and depending on what you plug into it determines what information you get from it. So it's the same wire for everything, and then you just pick, there's lots of threads, and you just pick up a thread and take it to the appliance that you need. So digital TV probably in all the bedrooms and the main living room in 2 places. Internet in every bedroom, in the kitchen, and in 2 places next to the TV. And then What else did we say? And the phone in every room and in near the kitchen.
It's rare to find a house with a phone these days with a landline.
Yeah, but you still have to provide it because people need it to be able to make phone calls for emergency purposes.
So basically all.
Internet everywhere. I'm a big fan of more data ports and NBNs. Yeah, there is. Actually, the wireless is pretty good these days, but with blockwork, you don't get as much. It's a long way from kitchen here to bedroom 2. So hardwired in is better.
That story about that lady, I think it was in Estonia, where she was like cutting down wood for the winter, and she accidentally cut the main internet.
No.
And it cut down the whole entire internet connection to this one town.
Oh no.
Yeah, that's funny.
There's 3 lines from Asia into Australia for the internet. They both come sort of down through Hong Kong. 2 go down to the eastern seaboard and 1 goes down to the west. And 1 to Sydney got cut once under the ocean near Hong Kong. Slowed us down a little bit.
When I worked, it must have been, I think when I worked at Solomon mine site, or maybe it was MacArthur, one of the 2. And somebody hit the fibre cable somewhere nearby, and it cut the internet for like Telstra communications for like pretty much like everyone in that region.
Oh yeah. We've got a backup system here, so because there's a main line that comes across from Queensland for us to the Northern Territory, and that gets cut occasionally, but we have a backup system that's not as fast, but so if that goes, then we do have a backup system. The university, I say, we. So yeah, you want it to be a single bus port, and then you fan out to all the different locations, and it will probably go through the ceiling and down the walls and come out through the ports. You wouldn't do it in the floor and go up; you would go across and down in the same battens that we've got for our ceiling lining. So all the water and electricity and everything will all travel around in the ceiling. It's good to do in the ceiling because then if you need to change something or fix something, you just take the ceiling lining down to get access. If you trap it in the slab, plumbing drainage has to be trapped in the slab, but everything else, if it's flexible and available in the ceiling, that would be best.
I find that solution very generous.
It is. I'm a personal fan of generous NBN. That's my. You can cut back if you want, but that is. I consider that essential. I know. Don't even talk to me about where I currently live. It's just, yeah, it's bad. Cool. Is there any other services that we need?
Where would they get the service for the ducting and everything? When they have to do repairs and stuff, would they have to go to the where would they get the plans for it anyway? Sorry, for each.
I'm not following you.
Instead of like pulling down each tile, ceiling tile.
Oh yeah, no, they would use the drawings at the different.
Yeah, what would
specialists
the be?
So at the building branch in the building file.
Oh, okay.
Yeah, or the certifier.
Right.
Or the owner might have them.
Okay. Yeah.
So do a bit of research about how much per metre these services cost to install. It's cheaper than you might think. They're all different.
Yeah.
So power, water, NBN, air conditioning. Make some phone calls if you need to. Do a bit of Google searching. Oh, it's enough to answer. There you go.
And he'll probably answer the question saying how long.
It depends. Yes, it depends. Well, here's your string. Show him the plans.
So the cost here is for the installation of the...
Yeah, to provide and install. And we're just talking basic appliances.
Could you talk about basically the cables and labour and all the little things that come?
Yes, the little plates and buttons and light switches and fan switches and all the rest of it. Yeah. Cool. Well done. How are we doing for time? 4 minutes to spare. Woohoo! So I have a proposal for you. I think that we should delay beginning this conversation for AT3 until next Thursday. I think we should spend the afternoon consolidating what we've learned in our own words. How does that sound? I don't think it would be smart of me to start putting new information for a new project in your brains right this second. I think it would be much better if you were given the opportunity to make your own notes and start doing a bit of research on this particular project before we added more information about AT3. We do have the time, so rather than doing it all and then leaving you alone, we do a bit and then come back to you next Thursday for more. How does that sound?
Yeah.
All right, cool.
So Lisa, for like the research that we are doing now, that will go through like a bundle of reports.
Yeah.
And
so when I say research, all I'm asking you to research is the amount of kilowatts for the air conditioning systems and the approximate cost per square metre for the services. Everything else, you already have it, and the size of the hot water system. Everything else you already have, go no further than that. That's as far as you need to go as far as the report goes for the construction system. What you will be doing is just writing it out in your own words and putting in some images either that you sketch or that you source from the textbook to illustrate that system. So it's a sort of a ground up list: footings, columns, floor slabs, walls, doors and windows, stairs, ceiling lining, services, sort of chunk it.
So we like added, we probably end up
the checklist,
typing this.
Yeah, or the Word version is available, so you can just amend this one.
Okay.
And then you can either, or you can just scan in what you've done.
Yeah, but then, so in a similar layout, I add all the information about kind of what we are proposing.
Yeah, so create headings that follow the construction system in a sequence.
Yeah.
I'm just looking to see if I've got the example here. There's a good example in here of the materials, and I already passed it around, didn't I?
Checklist and the drawing attached with the report.
Pardon? Yes, the checklist and the drawings form part of the report. So don't feel like you have to repeat the checklist and the drawings in the report. Only describe the construction system in writing, because we haven't got that on the drawings. Yeah.
so does our report cover all 400163?
Yeah, so 4001 asks you to report on the construction system, the materials. 4002 asks you to report on the regulations, the NCC and the planning scheme. And 4003 asks you to write a report.
Oh.
So I'm doing it all at the same time.
Report.
Correct. Yeah.
But then we need to do for each type of building.
Yeah.
And then that means that we've done, how many is it, 9?
Mm-hmm.
So, nice.
But that's relatively 3 reports.
Yeah, 3 in total takes care of 9 assessments.
Yeah, that's a bargain.
I think so. I think it's worth it for the confusion that it sometimes creates. It's definitely a worthy payoff. Yeah. Yeah.
But are we gonna? Is it like the final? Putting it all together, is it gonna be done at home?
No, we'll have the next 3 weeks, 4 weeks. We've got till mid-September. Every day we're here putting it together. Yep.
Okay. But I'm just like kind of finalising it and making.
Yeah. So remember, part of the assessment is a draft to be checked.
Oh, okay.
Remember, first draft is a part of the assessment process, and taking that feedback back.
So this is a group activity.
No, you're all doing your own report.
Yeah.
We just are sharing the intelligence, if you like, now. Yeah, we're acting as the design team, but then you'll go away and write your own report, and then you'll bring the draft and get it checked, and then amend it.
But we will do it.
For me, it's really hard to do that stuff.
Yeah. There isn't much more new knowledge to give you, particularly this AT2. We've kind of come to the end of what's new to know about this project, and so now you can start thinking about the report itself. Yeah, but I don't want you to start thinking about what's AT3 information while you've just got all the AT2 information fresh. So if you spend a bit of time this afternoon turning what we've done into some draft report notes, then I haven't muddied the information with AT3 stuff. How does that sound? It is a bit of a convenience for me as well, because I've got something I have to do this afternoon. Not for the whole afternoon, but a couple of things that I've got to get done because we've got the open day here on Sunday. And I just need to set up the stall, and it'll only take me half an hour, but I've got to duck out and do that. And I have to pre-record a brief for a student that's coming in on Monday to do a Class 2 project. So, but again, they'll only take me, a few minutes, so I'll still be here around and everything. But I just thought, rather than start AT3 this afternoon, it just seems like a really bad idea. That it would be much better just to give you the afternoon to consider what you've already taken in. And feel free to talk to each other, like you've all just had the same information come to you. So don't feel like you have to sit in isolation. This is a design team. You would work in an office and you would collaborate. Just remember the report that you present has to be your own work.
And just talk all together and
of course. If you wrote something down and you can't understand what you've written, no. Nice thinking.
For the flowers.
So what? Sorry.
You got that drawing for the flowers.
I'm going to take a photocopy of all of these.
And then I'll give everyone a copy. Does everyone want a copy? Or?
Yeah, that's probably a good idea.
So 1, 2, 3, 4, 5, 6, and I'll do 7 for Andrew.
Thanks. That's very kind of you.
Yeah, I bumped into her on Wednesday at college.
Oh, did you?
And her son was up there, and I was like, oh my god, he's so cute.
Yes,
I didn't realize how blue
anything.
her eyes were. I saw her calls, and I'm like, is that Andy? I'm like, your eyes look really in my head. I was like, she's different. And she had a son with her. I'm like, oh, he's so cute. And saying how she was going to come this week.
She's going to try and do it on her own.
Yeah. But yeah, I said I'll try and send some notes on.
Awesome. Good on you. You guys are very excellent.
So Lisa, our report will be, the title of our report will be,
I just,
AT1.
yeah, well, I probably wouldn't call it AT2, but I would just perhaps call it the lot number and the class. And then the client, so who it's for, what it's about, who wrote it, and when you wrote it. Who, what, when, where, and why. So who, what, when, and where.
Okay. Thank you.
Well done, everyone. Go and have some lunch. Thanks.
Yeah, sorry I was late this morning.
No, you're fine, one. Seriously, it wasn't a problem. I knew you wouldn't be far behind.
Yeah.
So we kept busy doing a recap, and then you were here just in the nick of time. Perfect.